Okay, here we are at the Black Bean Bistro menu, and this is going to be a quickie, hopefully, to just explain units and measure. So I've stripped out the font styles on this, and so we're just basically back at the root of here's a paragraph, here's a heading 1, and here's a heading 2. So all browsers have a basic default font size, which is usually 16 pixels, just depending on the browser. And so this browser I'm using is Chrome on a Mac, and so if I were to define for the HTML, which generally that's what you do, is you web designers define what your default font size is, and if I said it was 16px, you will, oops, I forgot to say font size. 16 pixels what? Okay, so it's font size 16px, and I refresh this, nothing changes. That's because everything is in relation to it. So the paragraph here is 16 pixels, and then the heading 1 is bigger than that. How much bigger? Well, we don't know for sure. That really depends on how each browser displays how much bigger it does. But we do know that an H1 is bigger than an H2 and bigger than an H3. So it's just in relation, that's what it is. Now, if I made this, say, 20 pixels, everything gets a lot bigger, all in relation to one another, because it's based off the base font size. Now, many designers do this because they want to control how that comes in. However, control is kind of an illusion here. And each browser, as I said, can display things a little bit differently, but also a user can change their font size as well. So if there's somebody that suffers from poor eyesight, they might set their font size, their base font size, a bit larger, so that all text on web pages come in a bit larger. So what is a better practice to do is to set your base font size at 100%. So whatever it is they set it at, that's what it's going to be. If it's the default font size, it's going to be 16 pixels. But if they set it larger, well, then it's going to be larger, and everything's going to be larger in relation. So as we can see, nothing changes, so it's 100% of whatever that is. So the next thing to do is to define how big we want that H1 to be. So we can say H1, so we target that HTML element, and I'm going to give it a font size, font dash size, is the operation here, and I'm going to say 24px. So that should be twice 16 pixels. So, or 1.5 of 16 pixels. So as you can see, it got a little bit smaller. So we should ideally go and then define what H2 looks like. So H2 should be smaller than H1. Now they're about the same. So that's what you would go ahead and do, is define what your H1, what your H2, what your H3 looks like. But for this exercise, I'm just going to show you how to use the different units of measure, and we're all going to be targeting the H1. So I'm going to do another H1, and I'm going to copy this 3 more times. So paste that on down here, and I'm going to give this a class. So I'm going to duplicate this and then target each one separately with these different units of measure, so you can see how this works in relation. So the second one, H1, I'm going to say dot, because I'm starting a class, so dot EMEX, so M example. So then the next one's going to be dot percent EX for percent example. And the last one I'm going to do dot REM example. All right, so I have them here, and so that means I have to go down and duplicate this heading that I'm going to style differently for each one and give it that same class. So I'm going to refresh this. I can see that I have them all here. And so for my second one, it was class equals EMEX, and then the third one is going to be class equals percent EX, and then the last one is class equals REM EX. Refresh, nothing changes because I haven't defined anything yet. Okay, so if I go on up to EM and I say font size 1.5 EM. I refresh this, nothing changes because, as I said, 1.5 of 16 pixels, which we are assuming is the base font, is going to be 24 pixels. Now if I said 2 EM, you can see it's a lot bigger because it's twice the size of 16 pixels. So that's kind of easy, but if you were, to help you on this, there is a calculator you can use by the W3 schools. So the CSS, you go to W3 schools and you look up CSS, and right in there they have their CSS PX to EM converter. So in that you set your default size. So they just assume that your default size is 16, but you could change that to something else. And you can say, well, if your default size you set at 16, what is 1 EM? Convert. That's 16 pixels because 1 is just whatever it is. If I say it's 1.5, convert, it's 24. So it's 1.5 of that. Or it's 2, which is twice the amount of 16, which is 32. Well, what if you changed your default font size to say 18, and you want a pixel size value of 24, for example, convert that to EM, it's going to be 1.333333, and you have to have all those 3333s. Let's go back to say 16, and you wanted a default pixel size value maybe 34, and you wanted to do it in EMs, convert, and it's 2.125. It's a little bit better of a number, but as you can see, it can start to get a little confusing. So I'm going to stick back with 1.5. So back to 1.5 on this. So if that's 1.5 is 1.5 of a 16 base font, well then percentage should be font size equals 150%. So refresh that, looks all the same. So if I had it at 250, see, a lot bigger, so we want that. So 150. So REMs is the same thing. So same thing in the sense of how it works. It's just what it's based off of. So I'll explain a little bit more of that in just a second. 1.5 REM. And note that you can't go 1.5 space REM, otherwise it's not going to work. You have to do your number and then your unit of measure. Same with 150%, 1.5 EM, 24px. You can't go 24px and then space. You have to have it right next to it. So 1.5 REM, REM stands for root M. So it's based off the root size, which is the HTML font size up there. M's is a little more complicated because, as I said, it's complicated when you have these different in-between numbers, but in addition, you could define in a block a different font size for that whole block. So then it's based off of the size for that block, whereas the REM goes right back to the root. However, REM isn't accepted in all browsers. So actually what's the best thing to do, and what we're going to do the rest of these exercises, or the easiest to do, I shouldn't say best, it just depends on whether you are comfortable in thinking in these different percentages or different units of measure. We're going to define everything as 100%, and we're going to use the pixel base value for these. That's basically it. Now there is a VW which will resize it down. So for example, in all of these, if I resize my browser, you can see it doesn't change the size of the font. It doesn't shrink it down, whereas the VW, which is viewport width, will start to shrink it in relation to the size of the browser. So you have to make sure everything is defined in that viewport width if you want them to all to shrink together with it. But again, you have to have a fallback solution with a pixel base or EM base because it's not accepted in all browsers. It's getting better. But with this, you can change this pixel size dimension based on your viewport with something called media queries, which we'll get into later with the responsive web design. But for right now, we're just going to define one size for the pixels, and then we'll get into resizing it for the different screens later, to where when you get to a certain breakpoint, it will change to the different sizes. So hope that made sense and demystifies these different units and which one you should use. Basically, it boils down to what you're the most comfortable with, but most of all, just be consistent. If you're going to choose M's or percentages or REMs, do that for everything and don't mix and match. Otherwise, you won't know where you did one style with one and what's it based off of, and etc. It can get to be a real mess real quick.